welcome back. This is our third little episode of Ask the Pros about batteries, anything to do with solar efficiency.
Yeah, this week is efficiency.
This week is efficiency. So
yeah.
Right on. So question of the week is why is efficiency important?
Yeah. Now, who sent that in anyway? I mean, do you know or?
That was actually Tony Paoli from PMP Energy.
Ah, okay. Well, we want to provide the homeowner with power when needed. And we have the solar system that's generating power. The battery will store that energy. Then the inverter will provide power to the homeowner when needed. It's late at night or early in the morning. If there isn't enough power, then what do? If not enough, we've got to either generate more power,
correct,
or we've got to look at how we can reduce those losses.
Well, where do losses impact efficiency at?
Yeah, I'd say almost at every stage of the overall system, we're dealing with efficiencies. Mm-hmm. Let's start with the PV panel efficiency itself. Look at this slide from the National Renewable Energy Laboratory. It shows how the PV panel efficiency has continued to increase over the years. I mean, it's just amazing. As for a particular panel size, given a certain amount of photon solar, power shining on that panel, how much electrical energy you're able to get out of that is how they rate those solar panels.
Right. Yep.
And that power rating is also based on a fairly cool temperature. I mean, it's a steady temperature. Right. So how does the temperature impact, the solar output voltage if it's colder, Josh?
Well, so when it gets colder, the actual output and the voltage would go up.
Yeah. And likewise, if it's hotter, goes down, right?
Yep.
Okay. Well, if we take the DC power coming from our solar panels and we convert it to AC, bam, we've got 10% loss right there.
Right out of the gate.
Right out of the gate. And losses produce heat.
Right, yep.
Okay, so think about that. You're putting a small heater underneath the PV panel, and we know that heat will further reduce the power output from the PV panel, right?
Correct, yep.
Yeah.
Absolutely.
So let me get into a few little electrical power terminology things.
Yeah, let's start with the basics.
Okay, these are fairly basics, but we do need to understand those because power is equal to the voltage times the current. Voltage is represented with a V, and current, for some reason, is represented with the I. And that is what's equal to watts, which is represented by a W. So the good news is that it's the same energy that we're talking about, watts, whether it's DC or for AC RMS. And loads are at least thought of as resistance, resistive loads, and that's an R.
Right.
So, if you look at it, W equaling the I times the V, we want all of that voltage to go to the intended load. We don't want to be dropping voltages on connections, on wires, because even a wire has a resistance, right?
Correct, yeah. Size of the wire.
Exactly. You got to size the wire based on how much current is flowing. So another expression that's used, especially with the wire and voltage drops across the wire, is where the voltage is equal to the I times the R, so that we say that power, W, is equal to I times, now we substitute the I times R for the V, and we get W equals I times R, which is I squared R.
Right, efficiency.
Yeah, and those are the main losses that the electricians talk about in connecting everything within the system.
Right.
Okay, so we've discussed a little bit about the PV panels, and we've discussed a little bit about the wiring and everything to connect all the stuff together. Now, the last part is everything that goes inside the NeoVolta
Right.
NV14 and NV24. That's where semiconductors are used for conversion, and they actually have variable resistances as well. So, switching losses. Now, these graphs can be a little intimidating, I must admit, but we're really just talking about how these semiconductor devices are turned on and off 50,000, 100,000, maybe 250,000 times a second.
Yeah, that's crazy.
It is.
Fast.
That's the switching frequency.
Right.
So, when a semiconductor device is all the way on, then there's very low losses, on it. Current's going through, voltage is very low, low losses. When it's off, it's off, and so you have zero current, right?
Right.
All right, that's easy. It's just the transition between when it's off to on, or transitioning from on back to off.
Right.
That's where we're getting the losses. That's what's causing the heating, and that's what's providing a negative impact on the efficiency for the system. So here is the internal drawing on the NV14.
Okay. Yeah.
And when we're converting the solar DC to 240 volt AC, it results in losses about 10%. Now, converting the 240 volts AC to charge a battery has losses also. And because you have to, it first has to be changed to a high voltage DC, often using a power factor correction input to be able to boost the voltage to a high voltage DC. Then you've got to convert that high voltage DC back to the actual battery voltage DC.
Right.
Losses. Whereas if you take the high voltage DC coming from the solar panels and you bring that directly into the NV14, now, you use that to charge the batteries, and you're saving about 18% of the energy.
That's a lot.
So what does 18% efficiency difference look like? You and I were discussing it. We wanted to work up a system. So we first worked it up where this particular system, an 8.4 kilowatt of solar, would work fine if we ran the PV power as DC directly into the NV14.
Right.
Now, the AC alternative being 18% less efficient, we calculated we would need 9.9 kilowatts of solar panels on the roof.
Right. And that is 1.5 kilowatt more solar needed for
It
the same
is.
efficiency.
And the dealer we were working with on that one figured $4 per watt is what it was costing the customer.
Right.
$4 per watt times 1,500 watts, $6,000 difference to the customer.
Right. That is a huge savings.
It is.
Or a loss.
Yeah, and this is what you and I are trying to get across to so many of the sales and the installers.
Correct.
As far as the advantages of using the NeoVolta system.
Well, that brings us to our end of our segment for this week. We'd love to hear from you. Any comments, questions, please email us at mike@pmp-energy.com. And once again, if we do pick your question or respond back to you, we will send out a free PMP Energy hat. If you are looking to get certified, any installers out there, go to www.pmp-energy.com.
Yeah.
Yeah.
Yep.
And that's us.
And that'll take us there. And, some of what we've covered today might be a little bit more technical than normal. Hey, and if you've got questions in terms of what we're discussing, please email it to me. I'll cover going down in a little bit more facts and stuff with you that way. So, yeah.
Wonderful.
Get
See
a
you
hold
guys
of us.
next week.
Talk to you
Yep.
later. Thanks.
Bye.